Yes, sir.
derive expression derive expression for capacity of parallel plate condenser with dielectric of thickness P. One derivation we did, capacity of parallel plate condenser filled with dielectric medium, dielectric K throughout. That means if this is plate, throughout it was there. We had drawn this way and throughout there was dielectric. If you remember, it came AK epsilon 0 by D. If it is air, then it will become A epsilon 0 by D. Now we are telling, if we have got dielectric, not in full medium, but in between of some thickness T. So we want expression for capacity of that parallel plate condenser. Please write heading. Heading is done.
Yes.
Parallel plate condenser is dielectric medium of thickness T. This thickness from one end to other end is T. Now can you tell me, if this is dielectric, here we give positive charge, this has negative charge, then field here will be directed this way, no? From positive to negative. Correct?
Yes.
And in insulator, so this air वाला thickness कितना है? D minus T है क्या?
हाँ.
Correct. So just remember, air का thickness is D minus T and dielectric is T. Total is D. So if this is one plate A or M, N, charge is Q here, charge is minus. Due to induction, polarization, dielectric is not having free electron. Charge will get separated due to this electric field. So here we get minus, 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 minus. Here plus, 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 plus. So here electric field will be acting opposite to the outside one. Opposite. Just draw this much diagram. This I am giving the name E0 and inside वाले को E dash. Net electric field E dash. Yes, completed diagram.
Done, sir.
I'm clearing the diagram part. हाँ, देखो अंदर का इंटेंसिटी, ये पोलराइजेशन वाला और ये ई नॉट वाला दोनों का डिफरेंस होएगा ये अंदर, बिकॉज आउटसाइड इंसुलेटर से पास होएगा ना ये पूरा, और ऑलरेडी देयर इज दिस फील्ड इन ऑपोजिट, तो नेट क्या आएगा, डिफरेंस ऑफ दीज टू, करेक्ट? हेलो हेलो,
Yes, sir.
Yes.
okay, now one by one we'll see required derivation. Consider a parallel plate capacitor consisting of plates m comma n separated by finite distance t, filled with dielectric slab of thickness P, having dielectric constant K. Let A be area of each plate. M is charged with positive charge Q, and N is earthed due to electrostatic induction. N becomes negatively charged. Thus, electric field intensity due to charges on M and N, comma E equals to sigma, or we can write Q upon A epsilon naught. Write this much. Q upon A epsilon naught. Electric field intensity charge M and N, charge on M and N outside dielectric. ज़्यादा अच्छा है. Outside dielectric, comma E equals to Q upon A epsilon naught, equation 1. This much any doubt is there? Same as previous class. Hello?
No
Yes,
doubt.
sir.
Yes, yes. Okay then, right.
So done.
So we got intensity outside the dielectric is Q upon A epsilon naught. ये थोड़ा सा part I have not yet explained. Now see just meaning. The field E naught polarizes means separates the charges of dielectric which were bounded. The field E naught polarizes the dielectric. Polarizing means separating the charges. The field E naught polarizes the dielectric. Hence, charge minus QP and plus QP are induced on left hand side and right hand side of dielectric respectively. Hence, due to polarization, electric field EP is produced in the direction opposite to external field E naught. And EP will be given by charge QP upon A epsilon naught. Yes, please do this much. P means polarized. So wherever you see P, it indicates polarized.
Done, sir.
K will be the AK epsilon naught. I will do here. AK epsilon. Then,
Yes, sir.
okay. Therefore, the net field dash inside the dielectric is E naught minus E. Therefore, E dash equals to E naught minus EP, which is E naught upon K, since E naught upon E naught minus EP is given as K, is equal to K. So this E dash becomes E naught is Q upon A epsilon naught into this K. Therefore, charge Q is nothing but A K epsilon naught E dash. Shall I clear this now?
Yes, sir. Done.
Actually, ये क्यों नहीं निकालते तो भी चलता था, because only E dash we are interested in. Now we know that potential difference. What is potential difference in terms of E? It is E into distance. So E naught का distance is D minus T, and that E dash is having thickness T. So it is E naught D minus T plus E naught upon K into thickness T. Hello?
Yes, sir.
Therefore, V is
Yes.
E naught in bracket D minus T plus T upon K. Okay. Now, what is capacity formula? C equals to Q by V.
Yes, sir.
It's straight line, or E naught is Q upon A epsilon naught D minus T plus T by K. So my capacity will become Q upon A epsilon naught Q divided by B. So C equals to Q upon Q by A epsilon naught D minus T plus T by K. Q cancel. So C becomes A epsilon naught D minus T plus T by K. D minus T plus T by K. Right. So whenever there is dielectric of thickness T, value K, then capacity becomes A epsilon naught D minus T plus T by K. Completed?
Done, sir.
Okay. Thanks. So capacity, if it is parallel plate condenser filled with air, then A epsilon 0 by D, fully filled with another dielectric, then A K epsilon 0 by D, but with thickness T, then A epsilon naught upon D minus T plus T by K. अब ये पूरे का पूरा अगर थिकनेस D वाला रहेगा तो क्या होगा, ये कैंसिल होएगा, तो K ऊपर जाएगा, which we have derived in the last class, A K epsilon 0 by D. Okay? Hello?
Yes, sir.
Now three
Yes.
cases. Case 1. If dielectric fills up the entire space, that is thickness is D, then C will become A K epsilon 0 by D, just now explained. That means C equals to K times that in air, correct? Hello?
Yes, sir.
Yes.
That means capacity increases by factor K. So when you put dielectric of same thickness, then capacity will increase by factor K. मतलब पहला air, if it is 10, then by dielectric of 3 it will become 3 into 10 and so on. First case, write down.
So what do you have written in the last line?
Capacity increases by factor K. Capacity increases by factor K. Capacity increases by factor K. Done?
Done, sir.
Okay. Case 2. So you remember last class I told, if dielectric divides distance into two parts, d by 2, d by 2, then capacity is A epsilon d by 2 product upon sum. Are you remembering this?
Yes, sir.
So every time it may not be only of two dielectric, there can be many dielectric. Then see what is the formula. If the capacitor is filled with dielectric slabs of thickness T1, T2, up to Tn, then this arrangement is equivalent to n capacitor in series as shown below. This is 1, this is 2, last is this is K1, thickness T1, K2, thickness T2, last is Kn, thickness Tn. So this becomes combination of n condensers in parallel. Area is same. So capacity C is same area, same epsilon, and this T1 upon K1 plus T2 upon K2 up to Tn divided by Kn. So imagine only two are there of same thickness, d by 2, d by 2. So d by 2 you can take common, ये product upon sum ऊपर हो जाएगा. Second case followed. Second one, what is formula? Second में A epsilon naught thickness upon K1 plus thickness upon K2 and so on. So if thickness is d by 2, only two are there. Then see it will become same what we derived in the last lecture. D by 2, K2 plus K1 product goes up. Same we got no when two are in series, if you remember.
Yes, sir.
Yes.
Right, third second case. (15 to 22 May you are having holiday.
Done, sir.
Case. If the arrangement consists of n capacitors in parallel with plate area A1, A2 up to AN and separation T. That is like this. Separation is constant, but area is getting divided. This A1, A2 up to AN, where dielectric is K1, K2, Kn. So this is parallel combination. Correct?
Yes, sir.
C equals to epsilon naught, same, distance same. Inside we get A1, K1 plus A2, K2 up to AN, Kn. If A1 is same as A2, is up to AN, all are same, and it is nth part of area, then C will become epsilon 0 by D, A upon N common, inside K1 plus K2 up to Kn. So see, if it is only two equal part division, then epsilon 0 by D, this is A by D, K1 plus K2, same we got in the last lecture. Area is A by 2, epsilon 0 by T, and K becomes K1 plus K2. Are you able to recollect that?
Yes, sir.
Right, third case. So when it is series combination, we got area same, epsilon 0 same, and upon it became T1 K1 plus T2 K2 up to Tn Kn. And in series, area is A by N, epsilon 0 by D, K1 plus K2 dot dot dot. Completed?
Yes, sir. Done.
Okay. One more. Fourth one. For metals, what is K? For metals, what is K? Yes, for metals, what is K? Infinity. For air, K equal to 1.
Yes, sir. One.
And for insulators, ये लिखा था पहले आपको. For insulators, K is greater than 1. So in air, capacity will be A epsilon 0 by D. For metal dielectric, for metal dielectric of thickness T, C dash will become A epsilon naught D minus T plus T upon K, that is A epsilon naught B minus T plus T upon infinity, which will be A epsilon naught D minus T. Therefore, C dash upon C will become A epsilon naught D minus T into D upon A epsilon naught. A epsilon naught cancel. C dash will be D upon D minus T into C. Right. Please practice 2 times today after by writing. Then you'll understand and directly you can do the sum in the exams. So if metal of thickness T is brought, then the capacity will become D upon T minus T times C. From this clearly we can say C dash is greater than C, because denominator is smaller.
Done, sir.
Conductors. And properties in electrostatics. Means what are conductor and electrostatic properties of conductor. Conductor means they have free electron or bounded electron. These conductors, they have free electron or bounded electron.
Free electron.
So I can say first what are conductors if they ask in fill in the blanks or MCQ something. So we can say conductors are materials or substance. Conductance are material or substances which contains large number of free electrons. This we have done in lower standard also, which contains large number of free electrons. Hence, conducts electricity in the presence of electric field. That means when you connect battery, they conduct electricity through the conductor. Metals are conductor or insulator.
Conductors.
What about human body?
Conductor.
Also conductor. So metal, humans, earth is also good conductor, and animal bodies. They all are good conductor. Are all conductors. Thus, when they come in contact with current, the current flows through them. Due to negligible resistance. Current always follows path of least resistance. Just copy this much. So if they say why a person experiences shock when he touches wire, because his body is conductor of zero resistance, current flows through his body. This property is not that important because we are going to study even in current electricity, but properties in electrostatics for conductor is more important. Yes, written. Conductors are material which contains free electron, hence conducts electricity.
Yes, sir.
Okay. Electrostatic. Under electrostatic condition, conductors have following properties. Under electrostatic condition, conductors have following properties. Do we have electric field inside the conductor? See,
Yes.
electrons are in the state of random motion. So unless until you connect battery, you will not get electric field, because electric field is from positive to negative. So when electron flows, actually it is flowing from one end to the other end. So wherever it went, it left positive charge and negative charge it is carrying. So there will be field diagram. This way there can be n number of field. So like net flow is zero, net electric field inside the conductor is always zero. Resultant, individual there will be, but resultant is what? Zero. All would know why?
Yes, sir.
Inside conductor, net electrostatic field is zero. Inside conductor, net electrostatic field is zero. Potential anywhere outside the conductor and inside, they are same or different? Yes, same or different? Like this is one wire. So potential here, they are same or different?
Same.
Same. If resistance comes, then there will be drop. So potential at any point on the surface and inside the conductor is always same. Potential at any point on the surface and inside the conductor is always same. Copy 2 point.
Sir,
Yes.
sir, in the first point, it will be zero till we have not supplied the electric energy, right?
Till we have not connected battery, inside is zero. When current starts
Yes.
flowing, then we get field in opposite direction inside, from positive to negative, because this is the battery now.
Yes.
In static situation, static means in rest condition, when charges are not in motion. Inside conductor, charge is zero. Written all the 3 points?
Yes, sir.
So electric field inside the conductor 0, potential everywhere constant, no charge inside. Fourth point. Electric field just outside a charged conductor. Electric field just outside the charged conductor is perpendicular to the surface. Is perpendicular to the surface at every point. This we have studied in also properties of lines of modes. Like this is suppose metal conductor. Here we have given positive charge, here negative charge. Then everywhere field will be perpendicular to the surface. Outward for positive, inward for negative. This is the meaning. Electric field outside charged conductor is perpendicular to the surface at every point. Surface charge density of a conductor could be different at different points. Could be different at different points. Now, meaning of this, if surface is irregular, then more curved part will have more concentration of charge and flattened part will have less. So therefore, charge per unit area may not be same throughout. Only if it is uniform, then it is same throughout. Shall I clear this? Electrostatic situation in conductor wala properties.
Done, sir.
Done, sir.
Insulator. In insulators, the electrons are tightly bounded to the nucleus. Tightly bounded to the nucleus. And thus not available for conductivity. Thus not available for conductivity. Hence, insulators are poor conductor. That means they don't allow current to flow. it can be considered as collection of molecules that are not easily ionized, because losing of electron or gaining of electron is called ionization, are easily ionized. They can carry distribution of electric charge on its surface or in its interior, that means inside. Hence, electric field inside insulator is not zero. Right. Like in case of conductor, inside electric field is zero, here electric field is not zero. So only two lines you have to remember. Completed? Hello, completed writing?
Yes, sir. Done.
Okay, now just three theories are left out. How we can separate the charges in insulator, that is called polarization, and what will be effect of polarization, because charge gets separated, therefore they will create electric field. So that effect we have to study of polarization. Next part is displacement current through through capacitor.